So here we have came up with a very interesting topic, that is hemolytic anemia due to G6PD deficiency, that is glucose 6-phosphate dehydrogenase deficiency. So just to tell that the biochemical aspect, that why this G6PD deficiency causes, that the exact pathway, that this enzyme is actually required in the hexose monophosphate shunt, and that all thing is already been recorded in my first year videos. So, and I've also put the link in my OneNote notes regarding this. Just adjacent to the marrow notes. Okay, so that exact video you can access from there if you need, but I don't think that you would ever need that. What you need to know is that due to the deficiency of this glucose 6-phosphate dehydrogenase, the oxidative stress in the RBC increases, and it just increases. It's like now the RBC are more susceptible to oxidative stress. Okay, so now we can have two things. So oxidative stress is increased. Oxidative stress increases. Okay, so due to this oxidative stress, we can have chronic, very minute level of intravascular or extravascular hemolysis. This is chronic but very minute to cause any symptoms or to be detected. Okay, but this because the oxidative stress is increased, so the other thing can be that in cases of high oxidative stress, what are those cases? Infections, faba beans, eating faba beans, and the third one can be anti-malarial drugs. So these three things are such that they actually increases the oxidative stress in the RBC, and now RBC is lacking G6PD. It is not there, so these three things can become fatal to the RBC. So after the exposure to either of these three things, about 2 to 3 days post exposure, we would get the signs of intravascular or extravascular hemolysis. We would get signs of both extra and intravascular hemolysis. So this part is written in Robbins, but not very evidently written. This part is very evidently written in Robbins, so must be kept in mind. So this part is like क्योंकि G6PD की कमी है, तो थोड़ा बहुत हेमोलिसिस होता रहेगा. It's like percentage थोड़ा बहुत हेमोलिसिस होता रहेगा. Okay, now let's come to the fact that why G6PD deficiency would cause hemolysis. So as the oxidative stress would increase in the cell, the oxidation of the globin chain would occur. Okay, oxidation of the globin chain is occurring. So the cross-linking of the reactive sulfidyl groups occur. So there are reactive sulfidyl groups in the globin chain, they get cross-linked. Now the globin chain gets denatured. After that cross-linking, globin chain get denatured. globin chain अब किसी काम की नहीं, globin chain हो गई खराब. ठीक है, अब वो खराब हो गई तो वो precipitate हो गई RBC में, precipitate in the RBC and forms Heinz bodies. Okay, now it forms Heinz bodies, और Heinz bodies जो precipitate होगी तो वो membrane से जाके चिपक जाती है, तो वो causes membrane damage. Okay, अब यहाँ तक हमें समझना है कि Heinz bodies formed. Okay, and bodies formed. Stuck. They got stuck to RBC membrane. Okay, now membrane damage occurred. Membrane damage occurred. Okay. Now this membrane damage can be enough to cause intravascular hemolysis. Okay, this membrane damage can be that much severe that it may cause intravascular hemolysis then and there, and that can give all the symptoms. We know that hemoglobinuria, and hemosiderosis, and also the other symptoms like let me see, the other symptoms maybe of the jaundice, icterus. Okay, so these things would be there. That is the intravascular hemolysis will be evident. Now the second thing that could occur is that membrane damage. Now these RBC, those are not lysed. Those are not then and there lysed. RBC reaches spleen. Okay, and then in the spleen, they the macrophages see abnormal precipitate, that is the Heinz bodies, Heinz. Okay, now the macrophages see those abnormal precipitate. Now those macrophages try to these are the Heinz bodies. Now the macrophages try to eat that particular. They try to eat that particular Heinz bodies. Okay, only that particular part of the Heinz body, and in that they also engulf a part of the cytoplasm of the RBC. So now RBC get converted into these bite cells. Now the Heinz bodies are not there, but the RBC get converted into this bite cell, because the Heinz bodies has been engulfed by this macrophage. Now so these bite cells, okay, these bite cells will pass. Maybe that the membrane loss is not enough to cause this bite cell, only small part of the membrane has been lost, but this would of course cause them to become sphere shape. We know that thing. Spherocytes formed. Okay, so these were the important things. So, and then we know that bite cells are abnormal. Bite cells are abnormal. They cannot sequester themselves by the small capillaries of the spleen, and these are also abnormal. So they undergo extra hemolysis. So finally they also undergo extravascular hemolysis, because their presence is also abnormal. So we know that a kind of stasis of these RBC would be there in the capillary bed of the spleen, and when the macrophages would detect them, they would eat them. So this is how it works. So that was it. So for the clinical diagnosis, we can find these Heinz bodies. So these are the Heinz bodies. And this is the bite cell, and maybe this should be the spherocyte, because the central pallor is absent, and this should also be somewhat hyperchromic to be very sure about that this is a spherocyte. So that's it for this video. Thank you.